Classmates, today we will introduce the classification of IP addresses. Before introducing the classification of IP addresses, let's first review the subnet mask and its function in a network. The subnet mask is composed of 32 bits in binary, represented by a sequence of contiguous 1s and 0s. The 1s correspond to the network bits of IP address, and the 0s correspond to the host bits of IP address. Its purpose is to divide the IP address into network bits and host bit. Now, let's proceed to look at the classification of IP addresses. IP addresses are divided into 5 classes: Class A, Class B, Class C, Class D, and Class E. Different classes are suitable for networks of different sizes. Class A addresses are suitable for large-scale networks. They use only 1 byte, 8 bits, to represent the network number, and the remaining 3 bytes represent the host number. Therefore, a Class A network can accommodate a large number of hosts. The first bit of the network number in Class A addresses is always set to 0. As a result, the binary range of Class A network numbers is 000000000 to 0111111, corresponding to decimal values from 0 to 127. According to IP address conventions, except for the first bit, which is always 0, the remaining 7 bits can be either all 0 second, 000000000, or all 1 second, 0111111, for special purposes. Thus, the valid range for Class A network numbers is 000000001 to 0111110, which translates to decimal values from 1 to 126. Therefore, the range of assignable Class IP addresses to users is 1.0.0.1 to 126.255.255.254. For example, if an organization is assigned a network ID of 61, the IP address range that can be allocated to that organization would be 61.0.0.1 to 61.255.255.254. The default subnet mask for Class A addresses is 255.0.0.0, which allows for 126 networks and 16,777,214 hosts per network. Class B addresses use the first 2 bytes to represent the network number and the last 2 bytes to represent the host number. They are typically used for medium-sized networks, such as regional network management centers. The network number of a Class B address always starts with 10 in binary, so the first byte can have values from 128 to 191 in decimal. Similarly, the default subnet mask for Class B addresses is 255.255.0.0, which allows for a range of assignable Class B addresses to users from 128.0.0.1 to 191.255.255.254. Class B addresses can support up to 16,384 networks, each with up to 65,534 hosts. Class C addresses use the first 3 bytes to represent the network number and the last byte to represent the host number. They are generally used for smaller scale local area networks, LANs. The network number of a Class C address always starts with 110 in binary, which translates to decimal values from 192 to 223, allowing for a range of assignable addresses to users from 192.0.0.1 to 223.255.255.254. Class C addresses can support up to 2,097,152 networks, each with up to 254 hosts. Class D addresses are used for multicast addressing, which allows data to be sent to multiple recipients at the same time. The address range for Class D addresses is from 224.0.0.0 to 239.255.255.255. Class E addresses are reserved for search, experiment and development. The address range for Class E addresses is from 240.0.0.0 to 255.255.255.254. Through the following IP address classification summary chart, everyone can clearly see the differences between Class A, Class B, Class C, Class D, and Class E. You must remember the following characteristics. Decimal range of the first byte. Fixed highest bit in binary. Number of binary bits for the network portion. Number of networks. Number of binary bits for the host portion. Number of hosts in each network. In addition to the 5 classes of IP addresses Class A, Class B, Class C, Class D, and Class E, there are also some special IP addresses. 1. 0.0.0.0. This address is used to represent all unknown hosts and destination networks. It is not a valid IP address. 2. 255.255.255.255. This address is the limited broadcast address used for broadcasting within the local network. Routers do not forward data packets sent to the limited broadcast address. 3. Loopback address IP addresses starting with 127 in decimal, ranging from 127.0.0.1 to 127.255.255.255. Represent loopback addresses. They are used to check if the network protocols are functioning properly. The loopback address 127.0.0.1 is used to refer to the local IP address. In addition to the aforementioned IP address classes, there are also reserved addresses within networks. 1. Network address. This address includes a network number with all host bits set to 0. It represents this network. For example, 10.0.0.0, 210.68.0.0. 2. Directed broadcast address. This address includes a network number with all host bits set to 1. It is used to send broadcast messages to all devices on a network or subnet. For example, 10.255.255.255, 210.68.255.255. Lastly, there are private addresses within networks, also known as reserved addresses or private IP addresses. These addresses are not registered and are specifically reserved for internal use within organizations. Organizations can allocate these IP addresses within their network on their own. Private addresses are only valid within the organization and are not routed to the public Internet by routers. The following are the ranges of reserved internal private addresses. Class A 10.0.0.0 to 10.255.255.255. Class B 172.16.0.0 to 172.31.255.255. Class C 192.168.0.0 to 192.168.255.255. Now, please complete the following assignments. The above is the content of our lesson today. Please complete the following assignment based on the study of IP address classification.